It's another Maker event, and we've got Wago, or Wago, I don't know how to pronounce it. I say Wago. Anyway, Wago connections. Fantastic piece of kit. So these are commoning blocks pretty much. So I'm going to grab one at random here. So a 221 for a look at this. Did I get it right? Yep. A commoning block. So you put one connection in, say ground, and all the rest of it becomes ground. So it snaps in place, put the wire in, reassuring click, holds on. In fact, it's held on that well. It's got a ferrule inside that one. Really handy for low voltage, and if it's proper Wago stuff, high voltage. So with this you can use mains power. In fact, you can go up to more than mains power. Check the rating before you use them though, but these are used quite often by electricians. I've got them in various sizes, various capacities. Got the old-fashioned ones here. I've got surface mount ones here as well, which I've yet to use, but Wago kindly supplied those a few years ago for me to play around with. But surface mount to Wago connections. Cool. But anyway, let me clear all this away and we'll get to the meat of today's show. What have we got today? Well, we've got some Wago clones. Again, these from Team. I'll show details in a moment. What happens with these ones is you've got two inputs here, so we'll say live and ground, and it splits it out into two of each. So I've got two live, two ground. Handy dandy. So I need to split up some circuits, send power somewhere else. Got it right there. I got three of these because it was pretty cheap. I'll go to the listing now. So it was £1.88 for three of them. That's three, two inputs, four outputs. And I thought, give them a go. It could have got bigger ones, a 2 to 6, but just wanted to try out these and see how they go. Would I use them for mains power? No. It says on the back of it, it says just about here. It's hard to get on camera. Well, have a go. No, it's grey unfortunately. It says, it's also upside down, it can take wire sizes from 0.08mm to 4mm, 600 volts at 32 amps. It says, have I tested it at that? No. Am I going to? No. This is low power stuff, up to about 12, 24 volts, something like that. I'd be happy to use these. Screw holders on the side so you can screw in place. You've got terminals in here to check that you've got power going in. So, with that in mind, let's build a quick and dirty circuit just to test that these actually work. One moment please. So here, a simple circuit. We have two LEDs, some 100 ohm resistors, and connections from this Wago clone, and a battery. That's running about 4.8 volts. It's 4 rechargeable cells, so 1.2 volts per cell, so 4.8 for the maths. Power goes in, power is split into two channels. So I've got two live, so 2.5 volts, and two ground. I've also colour coded them for you for easy reference. There we go. So if I turn this on, we'll see the LEDs light up. Nice and easy. So they're both getting 4.8 volts with resistors in line to drop the current, so it's not going to blow the LEDs like I used to do. Yay. £1.88 for three of them. Good for experiments. You can get more. You can get up to 5 pieces of each one. So 5 of each. I reckon they're worthwhile investment. Stick in the bits box. For your Christmas lights, for just general hacking around, for robotics, it'd be quite handy as well for splitting power to all the different devices that you've got. But yeah, nice and cheap, nice and easy to use. Anyway, see you later. It's bonus content time. Right, those two little holes in the back, those two just there, they should be able to tell us if there's voltage going through without actually having been plugged into this side. So we can check if it's working. So let's see if that's right. So we've got the LEDs lit. We know there's voltage. Got the multimeter in voltage mode, and I'm going to stick one probe in there and one in there. Nice one. 5.2. Ooh, I thought it was 4.8 because these are rechargeable cells. I was wrong. 5.3. So we can see there's voltage going through. We don't need to take circuits apart. We've got an inline way of testing that there is voltage. Anyway, see you later.